Hi boys and girls, it's Mrs. Bartell. So today we're going to be comparing rectangles with the same perimeter and then also comparing rectangles with the same area. Now normally, I'm looking at some notes that I wrote to myself in my teacher's manual. Normally I take a couple of days to teach this lesson in class. So I'm hoping that you watched the linked videos for the mini lesson before you get into this. And then the other thing you're going to need is I linked some centimeter grid paper, some dot paper, and you definitely do need this if at all possible. Have your parents print that out for you, okay? And I linked where you can get some of that. It's up in the materials for today, pretty sure. All right, so getting started on this, we are comparing rectangles with the same perimeter. And I am going to sit down here. Okay. Draw all possible rectangles with a perimeter of 12 centimeters and side lengths who are whole centimeters. So yeah, whole numbers. In other words, you can't do half numbers. So think about if it has 12, if it's 12 centimeters, we need to figure out the lengths of the two adjacent sides. Okay, so if I'm thinking about the number 12, I want to think about what adds to 12, and it would have to be divided by 4 different sides, right? So I'm going to just, it can't be 12 and 1 either, or 6 rather, and 1, because 6 and 6 is 12, and you can't have the 2 other sides. So it has to be less than 6. I do know that, because if you take 12, I probably just confused you, and you divide it into 2 equal parts, that would give you 6. So if you had 6 up here and 6 here, that's 12. And you can't have that because then you're missing these. And it can't go over 12 because that's the perimeter. So the number we're going to start with, I'm going to start with is 5. So 1, 2, 3, 4, 5. I'm going to do 5 here. And you know I like to outline these. 1, 2, 3, 4, 5, just to double check. 5, 1, 5, 1. So 5 and 5 is 10, 11, and 12. So that does work. Do you kind of see how that works? So I took this number, I divided it by 2, and I came up with 6. And you know you can't use that because then this side and this side wouldn't be accounted for. And you can't go over 12 for the whole total because of the fact that that is the perimeter. They just told you that. So we can use that. So if we can use 5 and 1, I'm thinking we can use 4 and something, right? So if I go 1, 2, 3, 4, 4 here, 4 plus 4 is 8. So I'm thinking it would be 4 and 2. See, I had 5 and 1, so now 4 and 2. 4 and 4 is 8, plus 2 more, 10, plus 2 more, 12. So if I did 5 and 1 and 4 and 2, I'm thinking I can now do 3 and 3, right? 3 and 3, which is a perfect square. 3, 6, 9, 12. Yep, it adds up to 12. Okay, so those are the ones that we can do for this problem. So if we were to write the lengths, we had the lengths of the sides. We had 1 centimeter and then 5 centimeters. And the area was, oh, we didn't find area, did we? All right, let's go back. I didn't find the area. The perimeter is 12. So the area for this, 5 times 1 is 5. 5 square centimeters. I almost said square units, but we're talking centimeters. So for this one, if we were going to list the lengths, it was 2 centimeters and 4 centimeters. And the area would be 8, right? 4 and 4 is 8. 8 square centimeters. Okay. And on this one, we had 3 centimeters. It was a perfect square, right? 3 centimeters by 3 centimeters, and it's 9 square units, or 9 square centimeters rather, altogether. Okay. So if we were to compare the shapes of these rectangles right here with the least and the greatest areas, think about which one has the smallest area. This one had the smallest area, right? And this one had the greatest area. They all have the perimeter of 12. This is 12 centimeters around, 12 centimeters around, 12 centimeters around. But the area is different on these. So look at what happens. The closer it gets to a square, the greater the area becomes. So they all have the same perimeter, but this long, skinny one has the smallest area. And then this is still a rectangle. It's still pretty long and skinny, right? And it still has a smaller area than this one. The closer it gets to a perfect square, the larger the area becomes. And that's what they're trying to get you to see on this, okay? So when it says to compare the shapes of the rectangles with the least and the greatest areas, I would probably say the long skinny one right here, right? The long skinny one has the smallest area. And then I would say the one that is a perfect square has the greatest area. Okay? So the closer and closer the side lengths come to each other, the greater the area grows on those. All right. So that's what you're doing, and you're going to do the same thing on this problem right here. The same thing. Okay, that's what this is. So remember how we did this one up here? We said that I took 12 and I divided it by 2 to get the 6, and we knew we couldn't start with 6. So I think I'll do the same thing here. Okay, the perimeter is 22. So if I take 22 and I divide it in half, that gives me 11. So I know for a fact I cannot start with 11. I'm going to have to start with 10. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 and 10 is 20, right? 21, and then 22 here. So here's 1. And this is 10. I just want to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I did it correct. Okay, so do you see how I did that? I took the perimeter of 22 and I cut it in half, and I came up with the number 11. And I know for a fact I can't have a side length of 11 because 11 and 11 is 22, and then I would have 2 missing sides. So that was too much. So then that's why I took it down to 10, okay? And I'm sure they're going to want us to find the area on that one as well. We'll come back and do area. So if I have 10 and 1, now think about this. I had 5 and 1, and then I went to 4 and 2. So if I had 5 and 1, it's just like me having 10 and 1, now I can go to 9 and 2, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9 by 2. 9 and 9 is 18. 18 and 2 is 20. 20 and 2 is 22. So here I have my 9 by 2. Now, think about what 1 less than 9 is. 8, right? So that if this is 10 and 1, 9 and 2, I'm thinking it's going to be 8 and 3. So 8 and 3. And we'll worry about areas later. But right now we want to get all of the possible combinations down. So this is 8 by 3. 8 and 3 is 11, and if you double that, that becomes 22. So now I'm going to take 1 down from here. I'm going to do 7. And I'm going to do one more mat. I'm going to do 4. 1, 2, 3, 4. Mine are kind of messy. Sorry, I'm trying to go fast. So 7, 7, 4, and 4. Okay. Now I'm going to do 6 and 5. And I think I'll do that. 6 and 5, I think I'll do that over here. I'm going to try to find where I can do it. 1, 2, 3, 4, 5, 6. Perfect. 5. 1, 2, 3, 4, 5. Okay, that worked out pretty well. So 6 and 5, right? This will be 6 and that'll be 5. 6 and 6 is 12, and then 10 more, 22. So that does work. Okay, so I think these are the only possible combinations, because if I went down from here, it would be 5, and then that would be 6, right? If you see, that was the pattern here. You take this first one. This top number decreases by 1 each time, and then this side goes up by 1 each time. Okay, so these are the only possible combinations. So we need to fill those in here. So we had 1 centimeter and 10 centimeters, 2 centimeters and 9 centimeters, 3 centimeters and 8 centimeters, 4 centimeters by 7 centimeters. And then we had 5 centimeters by 6 centimeters. Okay, so if we look at area, you can tell that the area is 10 here. And these are all going to be square centimeters. I'm not going to write square centimeters that many times. I'm going to put these little ditto marks because I'm lazy right now. All right, 9 times 2 is 18. 3 times 8 is 24. 7 times 4, 28. 6 times 5, 30. So you can see, look at here. You can see that the long, skinny one has the smallest area. And the closer and closer it gets to becoming a square, the closer and closer the side lengths become to each other, the greater the area becomes. So 10 and 1, those are far apart from each other. 9 and 2 are pretty far away from each other. The numbers that are closest together, the side lengths that are closest together in size, 5 and 6. And that's the one with the greatest area. So when it's asking you to compare the shapes of the rectangles with the least and greatest areas, you're going to be mentioning that the long, skinny rectangle, okay, the one with the side lengths that are farthest apart, has the least area, okay? The rectangle that is closest to a square, that has the side lengths that are closest to each other in length, that is the one with the greatest area. Okay, so that was this part. That's when they had the same, these all had the same perimeter. Now on the next side, we're going to be focusing on having some noticings and comparing rectangles that have the same area. Okay, so not same perimeter, same area. Okay, and we know if they are rectangles, they have 4 equal sides, right? Or 4, not equal sides, that's a square. 4 side lengths, rather, is what I meant to say. And they can have 4 equal sides. That would just make it a square, right? That would make it a perfect square. All right, so if we're starting with 12, what I would do if I'm starting with 12 for an area, I would think of 2 numbers that multiply to 12. What are some numbers that multiply to 12? And I'm, besides, well, you could do 1 and 12. You could do 1 and 12. 1 and 12 work. And I'm thinking 2 and 6 work, right? 2 times 6 is 12. 3 times what is 12? Think about that. 3, 6, 9, 12. 3 and 4, right? And those are the only ones we can do for this. You can't do 5 by anything. There is no number multiplied by 5 that would give you 12. So these are our only combinations that we're going to use. So we're good there. We actually have our lengths. And I'm going to skip writing the centimeters. You should be writing those though. I'm going to skip it by using these little ditto marks. I guess you could use the little ditto marks too. All right, so we need to draw those. So it's going to be 1, and of course we should label it, right, by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, boys and girls, the area is 12. There are 12 square units. Now we need to find the perimeter of that. It asks us to. And if you add up 12 and 12, and then add up 1 and 1, and then combine those two, you should be able to come up with your answer. I'm going to do 12 and 1 and then double it. 12 and 1 is 13, and I know if I double that, 13 and 13 is 26. And it's not square, it's perimeter. So they go around the outside, and to add that up, 26 centimeters. Okay, now I'm going to do my 2 by 6. I'm going to label it. I'm going to skip putting in my centimeters just to speed things up. But if I am adding up perimeter on this, 6 plus 6 plus 2 plus 2, I don't want to do all that work. I'm going to do 6 and 2, which is 8, and then double that. So 8 and 8 is 16. So there's my perimeter for this one. Now I'm going to do one that is 3 by 4. Oops, I went too far over. All right. All right, and if I were to find the perimeter here, it's 4 plus 4, and then 3 and 3, and adding all of those up. I'm going to do 4 and 3, and then double it. So 4 and 3 is 7, and I'm going to double that. So I can see that that is 14 centimeters. All right, now the job here is to compare the shapes of the rectangles with the least and greatest perimeter. Okay, so look at this. The long, skinny one has the greatest perimeter, And the one with the side lengths closest together has the smallest perimeter. Okay, so the rectangle with the side lengths that are farthest apart in distance as to being the same. In other words, this is 12 and this is 1. That's pretty far apart, right? 2 and 6, these numbers get a little closer to each other. 3 and 4 are very close. They're only 1 away from each other. So the one with the side lengths that are farthest apart in length from each other, in other words, this long, skinny one, that has the greatest perimeter. The closer and closer the side lengths get to each other, the smaller the perimeter is. Okay, so that is what they're trying to get you to understand. So now we are on one that is for 18 square centimeters, okay? And remember, this is area. So all 4 numbers have to add to 18. So you could obviously do 1 and 18. That multiplies to 18, okay? What other numbers multiply to 18? I think you should use the number 2 next. Kind of we went in order up here. So 1 and 18, 2 and, hopefully you came up with 9. Now you're going to go to 3. What number times 3 is 18? Do your count by threes. 3, 6, 9, 12, 15, 18, right? Did you come up with that? 6, okay? Those are the only ones. There is no number times 4 that is close, that comes up to 18. No number times 5 will be 18, okay? So these are your 3 dimensions that you're going to be drawing on this one, okay? And I think what you're going to find once you draw these out, I'm not going to actually draw them, but I think what you're going to find is that this one is your long skinny one, the farther and farther away the side lengths are to each other, it's going to have the greater perimeter. Okay, the rectangle with the side lengths that are closer to each other, it's going to have the smaller perimeter. All right, so that's what your lesson is for today. I'm not going to actually draw these ones out. You can do that on your own, but I'm pretty sure your results are going to be very similar to up there. Okay? All right, boys and girls, good job. Bye.